Download this code from codegive.com, link in the description below. Creating asynchronous functions in Python, a detailed tutorial. Asynchronous programming has become increasingly important in modern software development, particularly for I/O bound tasks like network requests, file operations, and database interactions. It allows programs to handle multiple tasks concurrently without blocking, leading to significant performance improvements. Python provides powerful tools for asynchronous programming, primarily using the async and await keywords, along with the asyncio library. This tutorial will delve into the creation and usage of asynchronous functions in Python, explaining the concepts, syntax, and best practices. 1. Understanding asynchronous programming, async/await. Before diving into the code, it's crucial to understand the core principles behind asynchronous programming using async and await. Concurrency versus parallelism. Asynchronous programming in Python primarily achieves concurrency, meaning multiple tasks appear to be running simultaneously. This is often achieved by switching between tasks when one is waiting for an I/O operation. This contrasts with parallelism, which involves truly running multiple tasks on different processors or cores. While Python's asyncio library itself doesn't inherently provide parallelism, it can be combined with multiprocessing or threading for scenarios where that's necessary. The event loop. The heart of asyncio is the event loop. Think of it as a central dispatcher that manages the execution of asynchronous tasks. It continuously monitors the state of these tasks, scheduling them to run when they are ready, i.e., when they are no longer waiting for I/O. Async and await keywords. These are the foundation of asynchronous Python code. Async. This keyword is used to define a coroutine function. A coroutine is a special type of function that can be paused and resumed during execution. It's the building block for asynchronous tasks. When you define a function with async, it automatically becomes a coroutine, returning a coroutine object. The function itself doesn't execute immediately when called. Instead, it creates this coroutine object, which represents a pending operation. Await. This keyword is used inside an async function to pause the execution of that function until another awaitable object, usually another coroutine, completes. Crucially, while the async function is paused, the event loop is free to run other tasks. This is what allows the concurrent execution. Await can only be used inside functions defined with async. Awaitable objects. Await works on awaitable objects. Common awaitable objects include coroutines, other functions defined with async. Tasks. Objects created from coroutines using asyncio.create_task. Tasks represent the scheduled execution of a coroutine on the event loop. Futures. Objects representing the eventual result of an asynchronous operation. The asyncio library often wraps underlying asynchronous operations, like network calls, in futures. Custom awaitables. You can define your own classes that implement the __await__ method to make them awaitable. 2. Creating a simple asynchronous function. Let's start with a basic example to illustrate the use of async and await. Explanation. 1. Import asyncio. Imports the asyncio library, which provides the tools for asynchronous programming. 2. Async def greet, name ** defines an asynchronous function called greet. The async keyword tells Python that this is a coroutine. It takes a name argument. 3. Print, hello, name. *** prints a greeting message. 4. Await asyncio.sleep, 2, ** this is the key line. Asyncio.sleep, 2, creates a coroutine that sleeps for 2 seconds. The await keyword pauses the execution of the greet function until asyncio.sleep, 2, completes. During this pause, the event loop is free to switch to other tasks. This simulates an I/O bound operation, waiting for something to happen. 5. Print, f goodbye, name. *** prints a farewell message. 6. Async def main, * defines another asynchronous function called main. This is often used as the entry point for your asynchronous code. 7. Await greet, Alice, * calls the greet function with the argument Alice. The await keyword makes sure that the main function pauses execution until the greet, Alice, coroutine completes. 8. Await greet, Bob, * calls the greet function again, this time with the argument Bob. Again, await ensures that main waits for greet, Bob, to finish. 9. If __name ___ main _ asyncio.run, main, *, this is the standard way to run the asynchronous code. Asyncio.run, main, starts the event loop and runs the main coroutine until it completes. Output *. Notice that Alice is greeted first, then Bob. After 2 seconds, Alice is given a goodbye, and then after another 2 seconds, Bob is given a goodbye. This demonstrates how the await keyword allows the event loop to continue processing other tasks while waiting. The greet coroutines appear to run concurrently, even though they execute sequentially due to the await statements. 3. Running coroutines concurrently with asyncio.create_task. To truly achieve concurrency, you can create task objects from your coroutines and run them simultaneously. Asyncio.create_task is the way to do this. Changes and explanation *. 1. Task 1 equals asyncio.create_task, greet, Alice, * instead of directly awaiting greet, Alice, we now create a task object from it using asyncio.create_task. This schedules greet, Alice, to be run on the event loop. Importantly, it doesn't block the execution of main. 2. Task 2 equals asyncio.create_task, greet, Bob, * similarly, we create a task object for greet, Bob. Now, both greet, Alice, and greet, Bob, are scheduled to run concurrently. 3. Await task 1 and await task 2 *. These lines are crucial. They tell main to wait for both task 1 and task 2 to complete before exiting. If you didn't await the tasks, main might finish before the greetings are completed. Output, the order of hello messages might vary. Key difference * in this version, the hello messages for Alice and Bob are likely to be printed very close together, because the tasks are running concurrently. Both greet, Alice, and greet, Bob, start executing at about the same time. The await asyncio.sleep, 2, in each function allows the event loop to switch between them. 4. Using asyncio.gather, for easier task management. If you have a collection of coroutines you want to run concurrently, asyncio.gather provides a convenient way to manage them. Explanation *. 1. Names equals Alice, Bob, Charlie * defines a list of names. 2. Coroutines equals greet, name, for name in names * creates a list of coroutine objects, not yet tasks, by calling greet, for each name in the names list. Note that greet, name, here is just creating the coroutine object, it's not running it yet. 3. Results equals await asyncio.gather, coroutines, ***. This is the core of the example. Asyncio.gather, takes a variable number of awaitable objects, in this case, coroutine objects, as arguments. The asterisk operator unpacks the coroutines list into individual arguments. Asyncio.gather then creates tasks from these coroutines and runs them concurrently. The await keyword pauses main until all of the coroutines have completed. Asyncio.gather returns a list of the results from each coroutine, in the same order as the input coroutines. For print, all greetings completed. And loop asterisk asterisk prints a message indicating that all greetings have completed and then prints the results returned by each greet coroutine. Output asterisk. Asyncio.gather is especially useful when you need to wait for multiple asynchronous operations to complete before proceeding with further logic. 5. Handling exceptions in asynchronous functions. Error handling is essential in asynchronous programs. Use try, except blocks within your async functions to catch exceptions. Explanation asterisk. 1 try, except block in fetch_data, asterisk the fetch_data function now includes a try, except block to handle potential value error exceptions. 2 if error in URL, raise value error, asterisk this line simulates an error condition if the URL contains the word error. 3 accept value error as e asterisk if a value error occurs, the except block catches it, prints an error message, and returns none, or you could re-raise the exception if appropriate. 4 asyncio.gather still works asterisk even if one of the coroutines in asyncio.gather raises an exception that is handled within that coroutine, asyncio.gather will still continue processing the other coroutines and return a list of results, including the none result from the failed fetch_data call. Output asterisk. The output shows that the fetch_data call for the URL containing error raised an exception, which was caught and handled. The other URLs were still processed successfully. 6. Awaiting non-coroutine objects with asyncio.to_thread, Python 3.9+. Sometimes, you need to use existing functions that aren't designed to be asynchronous, i.e., they are blocking. Python 3.9 introduced asyncio.to_thread, to handle this. Asyncio.to_thread runs a blocking function in a separate thread, allowing your event loop to continue executing other tasks. Explanation asterisk. 1 blocking underscore function, x, asterisk this is a regular, blocking function. It simulates a CPU-bound task that takes 2 seconds to complete. 2 await asyncio.to_thread, blocking underscore function, 5, asterisk this is the key part. Asyncio.to_thread takes the blocking function, blocking underscore function, and its arguments, in this case, 5, as arguments. It runs the blocking underscore function in a separate thread. The await keyword pauses the main function until the blocking function completes in the thread. This prevents the main event loop from being blocked. Output asterisk. This demonstrates how asyncio.to_thread allows you to integrate blocking code into your asynchronous programs without blocking the event loop. 7. Canceling tasks. Sometimes you need to cancel a task that is already running. You can do this using the task.cancel method. Explanation asterisk. 1 asyncio.cancel letterer asterisk this exception is raised within a coroutine when the coroutine is cancelled. You should typically handle this exception in your coroutines to perform any necessary cleanup. 2 task.cancel asterisk this method requests the cancellation of the task. It doesn't immediately stop the task, it raises an asyncio.cancel letterer inside the coroutine. 3 await task after task.cancel, asterisk it's important to await the task after calling cancel, to ensure that the task has fully completed its cancellation process, including any cleanup. The await task will raise asyncio.cancel in the main function, allowing you to confirm that cancellation has taken place. For try, accept asyncio.cancel in both long_running_task and main *. The long_running_task uses a try, except block to catch the asyncio.cancel and perform cleanup. The main function uses a similar block to catch the asyncio.cancel when awaiting the cancelled task. Output *. 8. Best practices for asynchronous programming ****. Avoid blocking operations ***. The key to effective asynchronous programming is to avoid blocking operations within your async functions. If you need to perform a CPU-bound or blocking I/O operation, use asyncio.to_thread, or a similar approach to offload it to a separate thread or process. Use await correctly. Always use await when calling other coroutines or awaitable objects. Forgetting await can lead to unexpected behavior. Handle exceptions gracefully. Implement robust error handling to catch and handle exceptions that may occur during asynchronous operations. Keep coroutines short and focused. Design your coroutines to perform specific, well-defined tasks. This makes your code easier to understand, test, and maintain. Use type hints. Use type hints to improve the readability and maintainability of your asynchronous code. For example, choose the right concurrency model. Asynchronous programming with asyncio is well suited for I/O bound tasks. For CPU bound tasks, consider using multiprocessing or threading, with the concurrent.futures module. Conclusion ***. Asynchronous programming with async and await provides a powerful way to write concurrent and efficient Python code. By understanding the core concepts of the event loop, coroutines, and tasks, you can create asynchronous functions that handle I/O bound operations effectively, improving the performance and responsiveness of your applications. Remember to handle exceptions, avoid blocking operations, and use asyncio.gather and asyncio.to_thread to streamline your asynchronous workflows.